This is AP Calculus AB. We're going to be talking about the mean value theorem and Rolle's theorem. Before we get into that, we're going to review average rate of change and instantaneous rate of change. Consider the values of the differential function f of x in the table below to answer the following questions. Plot the points and connect them on the grid. I've already plotted the points. We got 0, 1, 2, 5, 4, 8, 6, 10, 8, 11, 10, 10, 12, 8, 14, 5, and 16, 1. And then I just tried to make a nice continuous curve. In calculus, I added this stuff down here. I just put this table down here and this graph down here so I could see them easier. In calculus, the derivative has many interpretations. One of the most important interpretations is the derivative represents the rate of change of a function. When speaking of rate of change, there are two rates of change that can be found that are associated with a function. The average rate of change, which you did in Algebra 1, and the instantaneous rate of change, which we're doing in calculus. As a quick review, to find the average rate of change on an interval. On a closed interval, the average rate of change is the change in y values over the change in x values. Let's look at a tiny example here. Find the average rate of change of f of x on the interval from 2 to 12. Without looking at my table, I could say the average rate of change is going to be f of 2 minus f of 12 over 2 minus 12. If I look at my table, f of 2 is 5, f of 12 is 8, 12 taken away from 2 is negative 10. This is going to be negative 3 over negative 10. The average rate of change is 3 over 10. It's like you're driving in a car. The average speed this person went was 0.3 of a mile per hour. Pretty slow. Instantaneous rate of change. At a value x equals a, the instantaneous rate of change is the derivative evaluated at that value of a. Is the instantaneous rate of change at 4 greater than the rate of change at x equals 6? Justify your answer. Well, at 4, which would be right here, if we draw a tangent line at 4, that tangent line represents the slope that 4 would be. Slope of the tangent line represents the slope of the curve at 4. If you find the slope at 6, sorry about that, it would be a little bit more like this. This tangent line doesn't have as near as big a slope as f of 4. So is the instantaneous rate of change of f at x equals 4 greater than f equals 6? Justify your answer. Well, I would say that the tangent line drawn at x equals 4 is steeper. By steeper, we're saying has a larger slope. Than the tangent line drawn, that twice, at x equals 6. Therefore, f prime of 4 is greater than f prime of 6. Done. That's a review of average rate of change and instantaneous rate of change. We're going to be using that when we talk about Rolle's theorem and the mean value theorem.